Hello, this video is for IXL Activity A1.A.7. It is titled Cube Roots, and the 3-character code for this activity is Romeo, November, Tango. So our first question is, what is the cubed root of 27? So first let's do a little bit of discussion about what are cubed roots. In a previous lesson we talked about square roots, and now we're talking about cube roots. And just like we talked about the root of a square and square roots, now we're going to talk about the root of a cube. You might remember that whenever we talked about square roots and we talked about what is the root of a square, well, we know that a square has 4 equal side lengths, and the root is the length of one of those sides. So now we're going to be talking about, well, what about cubed roots? And so over here I have a cube, you see that, and we know that a cube has 3 equal sides. Its depth, its width, and its height. And in this case, I have a cube here that has a length of 5 for both its height and for also its length and also its width. So 5 cubed is 125, and if you start counting all these squares that would be in the cube, there would be 125 squares in there. So the cubed root of 125, if you had 125 units, arranged them in such a way that they made a cube, then each side length would have a length of 5. So the cubed root of 125 is 5. And that brings us to the discussion of perfect cubes. So a perfect cube is a cube that has a product of 3 equal integers here. So 2 times 2 times 2, these are all integers. 2 is an integer. So we multiply 2 times itself 3 times, we would get 8. So the cubed root of 8 equals 2. Likewise, 3 is an integer. So if we did 3 times 3 times 3, we would get 27. So therefore, the cubed root of 27 is indeed 3. So it's the product of 3 equal integers, or that is to say, the product of 3 numbers that are itself. So some number multiplied times itself 3 times gives us a value of the cube, and then the root of that cube would be whatever number it was that we were multiplying times itself. Also, I've provided here a list of the first 15 perfect cubes. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8, etc. For instance, 7 times 7 times 7 is 343. So you might want to get a list of these perfect cubes. I got this from a web search. I just typed in perfect cubes and went to images, and I found this image here. So you could do the same. You could use the one on this video if you'd like, or you could also go ahead and just search one up on the internet and copy it to your desktop on your computer and then kind of keep it as a reference. Next, I'd like to talk about a little bit of academic vocabulary related to radicals. That's what this symbol here is. This symbol is a radical symbol. The number that is underneath the radical we call a radicand. And now that we're dealing with cubed roots, we actually have this 3 out here in this case. Now that number could be a 4, a 5, a 6. It could be another number. Whenever it's a square root, we just assume that it's a 2, so we don't put the 2 there. But in this case, since we're talking about cubed roots, we have to show the index, and for cubes, the index is always going to be 3. So kind of think of it this way. You're asking yourself, what number, if I multiply it times itself, equal number of times equal to the index, that is to say some number times itself 3 times, is going to give me the number that's underneath the radicand here. So in this one here, you'd see, what is the cubed root of 27? Well, that answer would be 3. So the cubed root of 27 equals 3, because we see that here, 3 squared equals 27. And that works out really well for our first question. What is the cubed root of 27? So we see the cubed root of 27, 3 squared equals 27. So the cubed root of 27 is indeed 3. And this means if we had a cube that was 3 units high, 3 units wide, 3 units deep, then we would have 27 square units inside of that cube. So again, you might want to get a graphic organizer like the one you see here and kind of use that throughout this activity. That'll be really helpful. On our next slide, we see what is the cubed root of 0. So we could write that down as what is the cubed root. Our cube is 3, is our index. Our radicand is 0. So what number times itself 3 times gives us 0? Well, that's going to be 0 times 0 times 0, right? Equals 0. So in this case, the cube root of 0 is going to be 0. How about the cubed root of 1? What about the cubed root of 1? What number times itself 3 times gives us 1? Well, that's going to be 1 times 1 times 1, right? That's still going to equal 1, so 1 times itself 3 times is going to give us 1. So the cubed root of 1 in this case is indeed 1 itself. On the next slide, what is the cubed root of 8? So, well, we know that 1 equals 1, so let's go ahead and try 2. What if I did 2 times 2 times 2? What's that going to give me? So 2 times 2 is 4, and then multiply 4 times that 2, I'm going to get 8. So it appears that 2 times 2 times 2 is 8, so the cubed root of 8 must be 2. Now we can also check our cubed roots on a calculator. You could use the slide that I used here. We see that the cubed root of 8 is indeed 2. You could use this chart here to find your answer. Or we could also use a calculator in this case. So let me go ahead and grab my calculator. And we'll clear this out. Hit clear. Let's go ahead and clear the number history here, keystroke history. And then from there we'll go on. So cubed roots, where do we find cube roots on a calculator? Well, for square roots, we were able to find it right here. It's blue. You see it right here where my mouse is moving around. So we had to hit that second key, and then we could do a square root of, say, something like 64, and hit enter, and we'd see the square root of, oh, I hit clear. Let me hit 64 and hit enter, and we see that the square root of 64 is 8. However, we need to do cubed roots. So how do we get that index there? Well, if we go to math and we look here, we see that cubed roots are right here at number 4. So I'm going to select number 4, and number 4 automatically, it pulls that up. Cubed root of some number. Well, in this case, we were doing 8, right? So I'm going to enter 8, and then hit enter, and it's going to give me 2. So moving along to the next one, what's the cubed root of 1,000? So we're looking for the cubed root of the number 1,000. Well, we know the square root of 100 is 10, right? And there's 2 zeros in it. Well, there's 3 zeros here. So is it possible that if we take 10 times 10 times 10, what would that equal? Well, 10 times 10 is 100. And then 10 times 10, we're just going to throw another 0 on there, right? So we're going to end up with 3 zeros. And sure enough, we end up with a product of 1,000 if we multiply 10 times itself 3 times. And that is indeed our Radicand has a value of 1,000. So we know that our answer is 10. Now again, if I go ahead and I get my calculator here, let's try that. Let's take again, I want to go to the math menu. I want to select number 4, so I'm just going to push 4 here. I could hit the down arrows. Another way to do it is you could hit the down arrows, highlight 4, and then hit enter. That's another way to get to it, and it brings up the same cubed root situation here. So 1,000 is our number we're looking for. That's our Radicand, the number underneath the radical symbol. And we'll hit enter. And indeed, you can see that our answer is 10. 10 is the cubed root of 1,000. And let's look at our next slide. What is the cubed root of 64? Well, you could go back to that table, or if we thought our way through it, what number times itself 3 times is 64? Well, we know that 3 times 3 is 9, times 3 is 27, so the cubed root of 27 is 3. So let's go ahead and bump up 1. Let's try 4 times 4 times 4. We're just kind of guess and check, right? 4 times 4 is 16. And then if we do 16 times 4, indeed we would get 64. So it appears to be that 4 is the cubed root of 64. And then what is the cubed root of 125 on our next example? And I'll use the calculator to do both of these whenever I pull the calculator up next time. Well, if cubed root of 3 is 27, cubed root of 4 is 64, the numbers seem to be going up pretty high pretty quick. Let's go ahead and try 5. 5 times 5 times 5. And again, you could use that cubed root, those perfect cube chart that I had on that first slide. You could reference something like that. But we'll go ahead and check this out. 5 times 5 is 25. And then 5 25s, that is to say 25 times 5 is indeed 125. So it appears to be that the cubed root of 125 is indeed 5. So let's go ahead and pull up the calculator here, looking for that. And here I have my calculator. So let's go ahead and do cubed roots. We're going to go to that math menu. We're going to select number 4. It's going to bring that up. Let's put in 125. Hit enter, and indeed our cubed root of 125 is 5. And our first one there, we're going to go ahead and do math. Number 4, cubed root of 64. Hit enter, and we'll see that the correct answer indeed for that was 4. Okay, so let's go ahead and minimize the calculator there. What is the cubed root of a negative number? In this case, well, we did 1,000 a while ago, and we realized 1,000 is, 10, right? The cubed root of positive 1,000 was a positive 10. So in this case, we're looking for, what about a negative? Now, whenever we did square roots, we talked about that we never saw a negative radicand. That is to say, the number underneath the radical symbol was never a negative number. And that's because you can't have two numbers multiply times themselves and come up with a negative number. In that case, we would use imaginary numbers to deal with that. However, with cubed roots, it's a little bit different. If your index is a negative number, in this case, if your index is a odd number, in this case 3 is an odd number, then it's possible to have a negative radicand. And here's why. So we know 10 is the number we need to deal with, right? It's just that this is going to be a negative. So let's try negative 10. So if we do negative 10 times negative 10 times negative 10, let's see what we get here. Well, negative times negative is positive. So negative 10 times negative 10 is going to be positive 100. Then if we multiply this 100 times negative 10, well, 100 times 10 is 1,000, right? We're just adding another 0 on. But this is a positive 10, and positive times negative is a negative, so you can see that we end up with a product, negative 10 times itself 3 times, produces a negative 1,000. So this is indeed our radicand that we have here of negative 1,000. So it appears to be that it is negative 10. So let's try this. Before we make an assumption, let's go ahead, because I want to kind of draw an inference here. But before I do, it's always good to have more than one example. So let's see how that works out. So next one is, what is the cubed root of negative 64? So cubed root of negative 64. Well, we know that we've done 64 before, I believe, or at least we saw it in the table. And we know that that number is 4, right? Whenever we had 4 times 4 times 4, it produced for us a product of 64. However, we need this to be negative. So what if these were all negative 4s? Let's try this out. Negative 4 times negative 4 is a positive 16. Negative times negative is positive. Then we multiply 16 times 4 to get 64. But a positive times a negative equals a negative. So we're now at negative 64, which is our radicand. So it appears to be that negative 4 times negative 4 times negative 4 equals negative 64. Therefore, it was negative 4 that was multiplied times itself 3 times. So we end up with negative 4. So it seems to be that if the radicand is negative, whenever dealing with cubed roots, that the root itself will be negative as well, or I should say the cubed root, to be exact, is going to be negative itself. And that is indeed true. So let's go ahead and look at this using the calculator again. We'll go ahead and use the calculator on this. Let's go ahead and clear that out so we can get it back at the top, get all that old stuff out of there. And then let's go to math and enter number 4 to get cubed roots. Now, if you're using a cell phone calculator, you might be able to find cube roots on there. Some might have it, some might not. You can find a calculator that does cubed roots. If not, you might just have to do a guess and check. You would have to multiply that number times itself 3 times. You would have to guess, oh, is it negative 10, and multiply negative 10 times itself 3 times. Or is it negative 4, multiply negative 4 times itself 3 times. Those would be possibilities. So our negative sign is right down here by the enter. So I'm going to put negative, in this case 1,000. One more there, and hit enter. And you see indeed it is negative 10. Likewise, let's check the other answer. Hitting 4 to get that negative, or that cubed root symbol going there. And then let's put in negative 4 and hit enter. And oh, that's not what I wanted. I need the cubed root of, I put the answer in as the radicand. So yeah, 4. There we go. And the number was negative 64, not negative 4. Good. And indeed it is negative 4. So those checked out. Good to go. On the next one, which two integers is the cubed root of 96 between? Well, is 96 a perfect cube? No, it's not. If we go look at that list of perfect cubes, we'll realize 96 is not a perfect cube. Now, whenever we did square roots of not perfect squares. We did a number line to try to figure out where these would fall between. And in this case, I'm going to encourage you to use the calculator. If you don't have a calculator that'll do cubed roots, we'll go ahead and look at another way of doing that. So what is 0 times 0 times 0? That's 0, right? And what is 1 times 1 times 1? That would be 1. Does 96 fall between these two values, 0 and 1? No, it doesn't, so we can rule that out. 11 squared is, let's see, 12 squared is 144. 144. And 11 squared, I think it's 121. 121. Pretty sure. Let me double check. Almost positive. 11. Oh, I'm doing perfect squares. Mr. T, you're wrong. You don't want to do that. I'm doing cubes. Okay, so I need to find 12 times 12 times 12. So I'm going to do 12. Clear out my calculator here. On my calculator, I'm doing 12 times 12 times 12. And that's going to give me 1,728. Oh, that's the 12 side. Go over here. So 1,728. So it looks like these numbers are pretty doggone high, right? Let's try 11 times 11 times 11. And that's going to give me 1,331. So this is just kind of a rough way of working around it. If I multiply these numbers each time, does 96 fall in between here? No, it doesn't. These numbers look like they're going to be much too high. So 6 and 7 might be as well. I'm going to go ahead and go over to the 4 and the 5. This is probably going to be, and not only that, these are cubes that I have memorized. So not too bad. 4 times 4 times 4 is 64. And 5 times 5 times 5 is going to be 125. Does 96, the radicand, fall between 4 and 5? Indeed, it does. So it's going to be somewhere between 4 and 5. Now, another way we could have done this is if you have a calculator that will do cubed roots, we could go ahead and do that. And so I'm going to pull up that calculator there, and we'll check that out. So let's go ahead and go to math, find the number 4, cubed roots. Let's take the cubed root of 96. Let's see what we get there, and hit enter. We end up with a number of 4.578. So we'll just round this to 4.58. We'll just consider that 4.58. So where would this 4.58? This is the cubed root of 96 approximately. So where would that fall? Well, 4.58 is going to fall somewhere between 4 and 5. So that's using the calculator. That would be the quick way to do it. If you don't have a calculator that'll do cubed roots, then you can just kind of do a guess and check by multiplying those numbers times themselves 3 times to see what that product is, and then compare it to the radicand that you're looking for. On the next one, we could go ahead and you could use your perfect cube list and do that and find the numbers. 818, negative 818 is what we're looking for. So we know that these are going to be some negative numbers. But let's just consider the 818. What if we look at a chart? Let's go ahead and look at that chart. I'm going to go back to that chart of perfect cubes. 818 is the number we're looking for. And here's our chart. 818 is going to fit right in between 729 and 1,000. So it's going to be between 9 and 10. So let's go back to that other slide. We said that the cubed root of 818, this was a positive 818, right, would be somewhere between 9 and 10. It would be somewhere between 9 squared and 10 squared, or cubed, not squared. So it's going to be somewhere between 9 and 10. But this is actually negative number. So whatever that number is, we know it's going to be a negative number, right? Some negative number there. So it's going to be between not negative 9, not positive 9 and 10, but between negative 9 and negative 10 would be the numbers we're looking for. And negative 10 is less than negative 9, so we want to list our negative 10 over here so that whenever we consider these inequality signs, that this statement is true. So negative 10 is less than negative 9, so we're going to put that over here on the left, and then we're going to put the negative 9 over here on the right. Now, another way of doing this would be to use the calculator. So I'm going to go ahead, grab my calculator here, and we're going to look for the cubed root of negative 818. So go to math, number 4 for cubed roots, and we're going to put in a negative 818. Hit enter, and that's going to give us a negative 9.35. So the number we have is negative 9.35. So where would this negative 9.35 fall between two integers. Remember, we have to be using integers there, non-decimal numbers. So where would this decimal number of negative 9.35 fall? Somewhere between negative 10 and negative 9. Whenever I'm talking about where would it fall, I'm talking about if we had a number line, and on this number line, remember, negative 9 is greater, so it's going to be to the right of negative 10. So we're saying somewhere on this number line is going to be negative 9.35. So that would be right about here, negative 9.35. So this square root here, or cubed root, again, I've been doing square roots for a while, so I'm forgetting to say cubed. So the cubed root of negative 818 would be negative 9.35 approximately. And so that would fall right in between negative 9 and negative 10, or I should say negative 10, negative 9. On the next one, which two integers is the cubed root of negative 805 between? Well, we could go ahead and start multiplying these again and do some guess and check that way, or we could use that chart. So 805, right? Let's go ahead and go back to that chart and look at it. We're looking for 805, and again, that's going to be right in between 9 cubed and 10 cubed, correct? So let's remember it's between 9 and 10. So here we are back at this slide. So it's going to be someplace that's going to be a negative number, right? So it's going to be somewhere between negative 10 and negative 9. Is that one of our choices? Indeed, that is our choice right there. We could also use the calculator again to do that, and pull up my graphing calculator. And let's go ahead and we'll clear this out to get the work back at the top. Let's go to math, number 4 for cubed roots, and let's put in negative 805. 805. And that's going to produce for us a answer of negative 9.3. So we realize that that negative 9.3 is going to go somewhere right on a number line, would be somewhere right in between the negative 9 and the negative 10. On the next one, which number is closest to the cubed root of 48? Now this one here, whenever we did square root questions that were similar to this, we had to find a number that was closest to a square root of some non-perfect square, we were able to use a number line thing. On this one, I suggest that you use a calculator for it and get the result. But if you don't have a calculator that will do cubed roots, then we can go ahead and just test out some of these numbers. So 48, I think we're going to end up with like 4 cubed, right? 4 cubed is 64. So we know 4.5 cubed is going to produce something even greater than 64. 3 cubed is 27, right? And so if we went up 48, this might be a good try. Let's go ahead and try the 3.6. So in a calculator, I'm going to do 3.6 times 3.6 times 3.6. Now remember, this is if you don't have a calculator that'll do cubed roots, then you could test it this way. So on my calculator here in my hand, I'll do 3.6 times 3.6 times 3.6. And that's going to give me a result of, make sure I got it in there right, it's going to give me a result of 46.656. So maybe it's 3.6. Now 46 is a little bit under that, so I know that 2.5 would be too low. We already know that this one would be too high. And also I'm pretty sure that the 4.3 is going to be too high as well, because 4 cubed is 64, and that's a bit more than 48. Now, if I had a calculator that does cubed roots, which I do, so again, I'm going to grab my calculator again, and we'll kind of check our answer here. Let's go to math and select 4 for cubed roots. Let's put in 48, 48, and hit enter, and I get 3.63, so it's going to be like rounded to what? The 3.63, so we'll do 3.63 if I actually used a calculator to find it. And which one of these numbers is closest to it? Indeed, 3.6. So you could guess and check, and we did use a little bit of common sense there, realizing that 4 cubed is 64, which is more than 48. So we could rule out the 4s, and then we could go ahead and the 3 cubed, which is 3 is less than 2.5. 3 cubed is 27, so that would be too low. So we could kind of find our way there without a calculator that'll do cubed roots. So either way you want to do it, if you have a calculator that does cubed roots, though, it's a good way to check it is to go ahead and do that like I demonstrated. So last example here, we know that this is going to be a negative number on this case because our radicand's negative, and all of these are, oh wait, no it's not, we could rule this one out, right? It's positive. So we know that since it's a cubed root of a negative number, that our answer, the cubed root of our radicand there, is going to be a negative number as well. So let's see, 2 cubed is 8, right? Or negative 2 cubed is going to be negative 8. So let's think of this on a number. I think we could go ahead and do a number line here. Let's do a number line, and let's take some numbers that we have, that we do know. In this case, so let's go with negative 1, and let's go negative 2, and let's do negative 3 here. And negative 1 times negative 1 times negative 1 is going to produce for us a negative 1. Negative 2 times negative 2 times negative 2 is going to produce for us a negative 8. And negative 3 times negative 3 times negative 3 is going to produce for us a negative 27. Well, we're looking for negative 6, right? Some number times itself 3 times. So negative 6 is going to fall right in this area right here. Negative 6, right? This is going to be like negative 4 here. And so right about here we would have negative 6. So it looks like it's going to be like about 1 point, and this would be about a third of the 3/4 of the way through going this way, would be 0.75, right? So we're getting pretty close to negative 8. So let's give this a try. We're kind of reason this out. Negative 2 is going to produce numbers that are too big. Anything greater than 2 is going to produce a number greater than 8. So we can rule these out. So by default, we pretty much know the answer is going to be negative 1.8. Now we could check on a calculator, and I could put on my calculator negative 1.8 times negative 1.8 times negative 1.8. Make sure I got all that in there right. And that would negative 1.8 times itself 3 times is going to give me a value of negative 5.832. Okay, so that's pretty close to negative 6, closer than the other ones would have got us. Or we could go ahead and use the graphing calculator that will indeed do cubed roots for us. And let's go ahead and try that out. So math menu, and we're going to go number 4, and we're going to put in negative 6. Hit enter, and it's going to produce for us a negative 1.8. We'll round that to 2. Negative 1.82. So which one of the answers were close to negative 1.82? Well, negative 1.8. All right. So if you have a graphing calculator that'll do cubed roots, this is going to be pretty easy. And however, if your calculator won't do cubed roots, you can use some ideas of guess and check, or kind of reason things out using the idea of a number line that we did here. So all of these questions conclude my instruction for IXL A1.A.7 Cubed Roots. Good luck with your activity.